President of ACE 2014 to 2016, and he is the Medical Director at Genes India ART Bank. So welcome Dr. Charudat Joshi. Along with him, we have today Dr. Ved Prakash. Again, he doesn't need any introduction, but just let me add, he is the Lab Director at Southern Fertility and IVF Delhi and NCR. He's Master in Biotechnology. He's trained in IVF and ICSI from Andrology and IVF Lab, KK Women's and Children's Hospital, Singapore. He's having advanced IVF, ICSI and embryology biopsy training at AZVU Brussels, and he's the Vice President of Academy of Clinical Embryologists India. So welcoming you, Dr. Charudat Joshi and Ved Prakash, sir. So over to you.
Thank you, sir. Thank you so much.
Thank you, Swana.
I'm sharing my screen now. Just a small introduction of iHera. So I welcome on behalf of iHera and academic partner Zydus Cadila. iHera is the International Human Embryology Research Academy. Our aim is, it is online resource of embryology, and here we are sharing knowledge and experience to the fellow embryologists, and we are also involved in online educational activity like webinar and some other video modules we are going to launch very soon, and one newsletter is also coming soon. One thing is very good with us, that Dr. Jafar Ali give us one journal of reproductive biotechnology and fertility to use on behalf of iHera. Now it will be our official journal, and many more things are coming very soon. And in this platform, we are not working not like a society. It's just a online platform, which is only work for embryology. So our team is myself, and Dr. Sanjay Shukla, and Dr. Charudat Joshi is founder, and this is our advisory board, national and international. This is our UA team leader and team members are there. So you can find us on www.ihera.org, and you can contact us on this email address. And here I want to say that whoever is interested and want to work for embryology, they can join us, and you can contact us on this email address. So over to Dr. Charudat Joshi. Please introduce our speaker.
Hello, good afternoon to everyone.
It's my pleasure to... Sorry, Charu. Just let me share that another.
Yeah.
Sorry. Sorry.
Meanwhile, can I ask the participants to put their comments in chat box? And if they have any questions, they can put their questions in the Q&A box. Thank you.
Okay, so it's my pleasure to introduce my good friend Dr. Sarpreet Singh. As we all know him very well, he doesn't need much of introduction, but still he has done his MD from AIMS. He is a senior consultant and chief embryologist at Artemis Health Institute since 2009. IFS and ISHRE certified clinical embryologist. He is convener for IFS SIG Clinical Embryology 2018-2020 awarded for Best Convener Special Interest Group at Fertivision 2018-2020. He has been also awarded with Champion of ISAR Award at ISAR Conference 2020, and he is convener to IFS SIG Applied Genetics till 2022. And his main interest area is cryobiology and male infertility. We are listening Dr. Sarapjit Singh from last so many years, and I welcome Dr. Sarapjit Singh. And I would also have, I think that's hand it over to Dr. Sarapjit Singh. You are most welcome.
Thank you, Dr. Charu, for the kind introduction. So I would like to share my screen now. So the topic allotted to me is basics of embryo culture system. It's a very long topic, a very detailed one, but I'll try to touch upon the most important aspects rather quickly because already I think we are a little late on time. So please bear with me. If I'm unable to go in details, you can ask me the questions later on. So if you look at the journey of embryo, an embryo is an unbound suspended organism, and pre-implantation development, it ranges from the fertilized oocyte to the hatched blastocyst during a course of 5 to 7 days. Nutrition initially is dependent on its own cytoplasmic stores of maternal origin and the secretions of the oviduct and later the uterus. So the composition of these secretions differs as the fertilized the fallopian tube and ultimately moves to the uterus. So the cartoon at the bottom, it shows how the oocyte matures, is fertilized, cleaves, compacts, then cavitates, and finally implants. So if we have to develop a culture system, we have to replicate the conditions of the maternal reproductive tract. With that thought, various culture system was developed, and the culture system, its main functions are to maintain the viability of gametes such as sperm function and oocyte competence, decrease embryonic stress such as temperature, pH, osmolality, and CO2 fluctuations. And these will help in ensuring a normal embryonic development and leading to increased in pregnancy and implantation rates. If you look at this figure, I am sure everybody must have seen this figure in Gardner. It shows that the culture system consists of not only the culture media, but also a gas phase type of medium overlay, the culture vessel, incubation chamber, ambient air quality, and even the embryologists themselves for that matter. The concept of embryo culture highlights the interactions that exist not only between the embryo and its physical surroundings, but also between all the parameters of the lab. So now we will go on to discuss the various the embryo culture system, and we'll like to discuss them in the subsequent 4 headings: culture media and consumables, culture conditions, quality control, which we'll cover along with the conditions, and culture protocols. Like Harper in 2012, she said that it remains true that there is no culture media available which is truly optimized for human embryo development. And in 2020 also nothing much has changed. That statement holds good. So if you look at the culture composition, it primarily consists of salts such as sodium chloride, potassium chloride, and calcium chloride. And we need high potassium levels because they are beneficial for sperm capacitation and general embryonic development. Calcium is essential for embryos to undergo compaction. NaCl and other salts, they help in maintaining an ionic milieu, which determines the pH also. And extracellular ion concentrations can have a profound effect on intracellular ion levels, and therefore the regulation of normal cellular processes is ensured with a proper ion concentration. The premature removal of cumulus cells in an ICSI procedure may render the oocyte susceptible to ionic stress if the salts are not in proper concentration. Moving on to the next slide, which shows the energy substrates, and we'll just touch the very important aspects here. Pyruvate, lactate, and glucose are the chief energy substrates. In pre-compaction embryos, they prefer pyruvate, followed by a shift to glucose in post-compaction embryos. And most culture media provide pyruvate at the same concentration as in fallopian tubes. They also have amino acids and EDTA, which limit the utilization of glucose during the pre-compaction stage, whereas glucose becomes a preferred energy source in post-compaction embryos. Amino acids, their chief function is energy source. They act as osmolites, buffers of intracellular pH, and antioxidant chelators. It has been shown that even transient exposure of zygotes to medium lacking amino acids impairs subsequent embryonic developmental potential, and their inclusion enhances embryonic development to the blastocyst stage. Now I have classified the amino acids into cleavage amino acids, which is primarily the non-essential amino acids, and compaction amino acids, which is non-essential amino acids and glutamine, which help in blastocele formation and hatching, whereas the essential amino acids and glutamine, which help in the development of ICM, or the inner cell mass. So cleavage is non-essential and compaction is both essential as well as non-essential. Addition of glutamine to a simple culture media significantly increase the development of human blastocysts in culture and increase PRs. Many studies have shown this. But again, glutamine, it comes with a drawback that it spontaneously produces ammonium as a byproduct. And impact of ammonium accumulation in culture media is a great concern, and its effect is magnified in 20% oxygen or atmospheric oxygen incubators. It alters embryonic differentiation, alters gene expression, and significantly reduces implantation and developmental rates. A simple solution has been the introduction of glutamine in a dipeptide stable form, which doesn't break down at 37 degrees Celsius. So the ammonium accumulation is very well controlled. Other components are chelators such as EDTA. It chelates potentially toxic metals. It may be involved with glucose metabolism by limiting the availability of glucose as an energy source in pre-compaction embryos. It stimulates development prior to compaction, but its presence in post-compaction embryos loosens the inner cell mass, leading to the higher possibility of monozygotic twinning. Certain components such as hyaluronone, insulin, vitamins, they have limited clinical evidence and are beneficial in certain class of patients, but not all. Antioxidants such as lipoic acid and essential nutrients like choline and ascorbates are also added, and their effect has been significantly seen in embryos cultured in atmospheric oxygen, that is 20% oxygen, and not in trigas or 5% oxygen incubators. So the antioxidants guard against the ROS release due to culture at atmospheric oxygen. This figure shows the same. You can see that figure A and figure A and figure C, you can see that there is a significant improvement when antioxidants are given compared to, and this is atmospheric oxygen, whereas figure B and D, this is 5% oxygen culture, in which the antioxidant effect is not that pronounced. Growth factors like GM-CSF and it's added, and it is again beneficial in certain patients, very guarded prognosis and recommendation for adding EGF, IGF, PAF, etc. And there is insufficient evidence to support the addition of such bioactive substances. So don't go by company guys who say that's a risk with GSF and please buy this. Buy it. A lot of research. Buffer system is a very important component of culture system. It helps in maintaining the physiological pH between 7.2 to 7.4 in the media. The buffers are selected on the basis of their pK values. pK value is the ability to resist pH change. As pK value needs to be matched to the application because many biological processes only function over a narrow range of pHe. The simultaneous use of multiple buffers is recommended as it allows for adjustment of pK values to the desired range. It reduces the individual buffer concentrations and potentially it elevates the concerns as the less doses used, so they're less toxic also. The most common buffer used is the bicarbonate buffer, which helps in fertilization and sperm capacitation. And HEPs and MOPs are also added, which help in when we are working outside the incubator. An advantage of bicarbonate system is that it is the physiological buffering system in fluid surrounding mammalian cells. A major drawback, however, is the rapid pH increase, which occurs when the medium is exposed to air. And the easy solution is to layer it with oil and replace 20 millimoles of bicarbonate with HEPs, leaving 5 millimoles bicarbonate. And this doesn't require a CO2 environment and can be used for short-term incubation or short-term use outside the incubator for around 10 minutes. Phenol red was a very common addition in earlier medias, but now it's not very commonly seen. It's a quality control to monitor medium pH. It becomes light pink in color when the media is nicely incubated. But now there are hypothetical risks based on its estrogenic activity, and it can be a source of ROS. Particularly in this era of microdroplet culture, a color indicator is neither necessary nor beneficial because visual assessment is anyway very difficult to standardize. Coming to oil, an oil overlay is recommended, especially when you are culturing microdroplets, and it prevents the evaporation of media, thereby decreasing the harmful effects of increase in osmolality, changes in pH, prevents risk of temperature fluctuation. So an embryo-tested paraffin oil is recommended, which also helps in trapping a number of years. A short note on the handling of oil. Oil should be stored in dark and in glass. It should not be stored for extended periods in the incubator. It should never be aliquoted into tissue culture flasks as they are styrene based, and oil is able to leach styrene from such containers at high rates over time. Oil is susceptible to photo-oxidation or peroxidation with the accumulation of peroxide levels that are damaging to the embryo culture. So please store oil inside the refrigerator, inside its and handle it, expose it to the light on a minimum basis. A short note on medium storage: ensure that the cold chain is not broken during transport of culture media between manufacturer to the clinic. Again, you have to avoid light exposure. Two of the most labile components are amino acids, particularly glutamine, which leads to production of ammonium. And the medium has to be stored continuously at the appropriate temperature. Refrigerators designed for medical storage with transparent gliding stores should be used, and not the kitchen refrigerators. Media is sometimes aliquoted into smaller volumes after delivery, and this plasticware into which they're aliquoted may release VOCs. So you have to be very careful about the plasticware. It should be equilibrated for temperature and pH for 4 to 6 hours before use. And it should be placed in the incubator for a minimum time required for equilibration, and they should certainly never be stored in the incubator. One second, there is some, yeah, it's moving now. Culture conditions. The next broad heading is culture conditions. Optimization of culture media can never be achieved by optimizing all the other components of can be achieved only by optimizing all the other components of culture system, including environment and equipment. So you have to optimize the lab culture environment as well as the lab environment for the pre-implantation embryos to develop in the most healthy and most implantable way. If you look at the culture environment, it is the temperature, oxygen, CO2, pH, osmolality, humidity, VOCs, and particulates. Whereas the lab environment, the important parameters are temperature, pressure, air changes, humidity, VOCs, and particulates. Coming to temperature, using and maintaining the appropriate temperature during cell handling and culture is a critical component of optimizing IVF culture system. I'm sure all of us have seen those studies by Wang et al. In which they show the retardance of meiotic spindle goes on decreasing with changes in temperature. It does recover at times, but you can never be sure about the recovery. Again, there was a lot of debate about the ideal temperature to use in vitro, as the testicular temperature is 2 to 4 degrees lower, and temperature of the female genital tract is also lower than core body temperature. It was shown by Higdon et al. That a temperature of 36.9 degrees gave better results compared to temperature of 37 degrees. But recently, it has been shown that the current IVF media is designed for use at 37 degree. And if you look at this Cochrane review, it shows that temperatures below 37 degree may give better outcomes, but they're not supported by a Cochrane review. And it is recommended that you have to use the media at 37 degrees only. So don't fiddle with your incubator temperatures, rather ensure that they are set at 37 degree. Another thing I wanted to highlight was that you should always cover your dishes, whatever dishes you make, open or micro droplets. You should cover them with oil as well as with the lid. And this study just shows that the center well dish attains the best temperature compared to a nunk or a micro droplet culture dish, which is not surprising because at times there is a small layer of a small lip of plastic which forms an air barrier beneath a dish and prevents the effective transmission of heat across the dish into the medium and the oil. A very important parameter is pH. The internal pH of embryos is 7.1 to 7.2. Any external pH that drifts too far away from pHi is likely to cause stress. Therefore, pHe should be slightly higher than pHi to help offset the acidification that occurs as a result of intracellular metabolic process. Denuded oocytes cannot regulate pH, so the pH should be optimally set on your incubator. A 0.2 variation in pHe is actually a 60% changes hydrogen ion concentration. So you have to be very particular about the changes happening in pH as they drastically affect the embryonic development by impeding sperm function, oocyte competence, gene expression, cell number of blastocysts, implantation, and they can also lead to a fetal growth retardation. You should always measure pH at some point of time, like we do it every 3 months in our lab, and then we kind of use our CO2 analyzer to check. Another way of doing it is you can check your dry gas supply. If your supplier is good, then you can calibrate your CO2 analyzer by checking the CO2 in the dry gas mink incubator or the dry gas cylinder. If you're confident that he's supplying 6%, so you can adjust the other incubator accordingly. You should maintain a very narrow and stable pHe. Factors affecting pH levels: length of incubation time, minimum 14 hours. The door should not be opened very frequently. Type of CO2 sensor, such as IR sensor, recovers pH much more quickly compared to a TC sensor. Volume of media and oil: increased volume means increased time. Humidity is important. Altitude: increase CO2 pressure in your incubators as altitude increases. Method of measurement: pH meter. There is a lot of user error. Blood gas analyzer is recommended, but it takes time to standardize. Just to emphasize the importance of keeping the dishes in a constant environment, if you bring out a dish containing 50 microliter of medium under oil, regassing takes around 20 times longer time than degassing. Therefore, it is recommended not to expose the dishes for more than 2 minutes. Always remember that increase in CO2 by 1% is equal to a 0.07 or roughly 0.1 change in pH. This is just the devices which are used to measure pH, and nowadays there is a real-time device which is available, which is shown in green color in the right bottom. So you can use this, but then it doesn't rely on a standard that might affect the pH of the media. Osmolality: optimal osmolality is between 260 to 290 milliosmoles. Control of osmolality is important, as the study by Swan shows that as the osmolality increases, embryonic development decreases across right from 6 hours of embryonic development going up to hatching. The embryonic development goes on decreasing. Changes in osmolality can make embryos change their volume. It can lead to cytoskeletal damage and alter gene expression and gene imprinting. This is a very important graph which shows that volume, temperature, and airflow affect, and as well as oil covering, they affect the osmolality of a dish. So if the temperature is low, the airflow is low, or there is no airflow, you can switch off the fan of the laminar. A larger volume drop and an underlaid drop type, they are able to produce a dish which osmolality is within normal limits compared to making a low volume dish with a fan on and a 37-degree temperature. So this is the way how you should make drops. You should make drops, cover them with oil, aspirate them back, and again release some media on the impression of the drops. So this is known as the underlay technique. So how to prepare a dish? Underlay drops, one dish at a time. Airflow should be minimum or no airflow. Stage at room temperature, cold media, cold oil, and use maximum oil. Type of dish should be specific for IVF. Air quality. It is said that the grade A air, which should be the air quality in the laminar hood, should have less than 0.5 microns particles at rest as well as during operation, whereas the lab should be at least grade B with less than 3,500 microns at rest and 350,000 micron, less than 0.5 micron particles can go up to 350,000. So the basic air sampling and VOC determination is important. VOC levels as low as 0.2 parts per billion can be embryotoxic. Lab should be overpressurized. It should be able to flush out all the VOCs and contaminants. Frequency of air changes should be at least 15 to 18 with a relative humidity of 40% and temperature of around 25 degrees Celsius. This is the optimal air quality which will help you optimize your culture media results and overall culture system results. This is what we do is we take a 100 mm dish and put some oil. It acts like an oil sink. It can absorb VOCs. It can be used even in holding incubators. And this is a product available from AquaGuard. It is activated carbon, which you can place in steel plates or steel holders and just lay them so that there's a large surface area. They also tend to absorb VOCs, but they have to be changed every 3 to 4 days. A strict quality control should be maintained. Optimum set points and tolerance should be defined for each culture system, and they should be independently calibrated. NEST devices should be used. Temperature, CO2, O2, microscopes, everything should be calibrated daily. pH can be done weekly, but it's very difficult to do it weekly if you don't have a pH meter. So a 3-monthly pH with regular adjustments from PO2 analyzer is the norm. Real-time data loggers should be used because they kind of track the changes, and abnormal findings are reported to the lab director, and he can take the proper measures to correct the things. QC of material and supplies. There are some materials in the lab which are not more symbiotic, such as serological pipettes, centrifuge tubes, culture tubes, gases for the maintenance of CO2 levels, filters for gases. So embryo should never come in contact with any embryotoxic substances, and the things which I mentioned, you should always run a sperm survival test on them because they're not now embryo tested. So run a sperm survival test on new batch and then start using it. Now we'll just touch upon culture protocols. First, we'll do it under the following headings: atmospheric versus low oxygen, sequential versus single step, cleavage versus blastocyst, humidified versus dry, open versus droplet, and single versus group culture. These 6 headings will just touch upon the culture protocols. It takes around more than 5 hours for the oxygen concentration to fall to embryo safe levels. So it is better to, if you're using a tri-gas, better to make dishes and put them in tri-gas incubator rather than equilibrate the media in a single gas, and then next morning you transfer them. You make a dish with the media equilibrated in a single gas, and then you make a dish and put it in the tri-gas, and straight away you start your work. That's not the way. You should actually make the dishes in the tri-gas, and or else wait for 5 hours and then start using the dishes. The oxygen in atmospheric oxygen incubators, there is a lot of ROS produced, which works with ammonium to disrupt the pathway of glutamine and alanine, leading to abnormal fetal development. It also increases the production of ROS, which can affect embryonic growth negatively. So the norm is that you should use oxygen at 5%. Unfortunately, I was reading the data on these incubators. Only less than 25% incubators are with oxygen control or low oxygen incubators. There is 75% or more than that are single gas incubators which are used across the world. This meta-analysis shows that 5% oxygen does better if you take the indices such as live birth rate and implantation rate. Even if you do a cleavage transfer or if you do a blast transfer, low oxygen incubators do much better and they should be used. If you look at sequential versus single step culture, the advantages with a single step with no renewal is that all the autocrine and paracrine factors and growth factors, they remain in place and they are not lost, which are lost with the renewal of sequential or a single step media. But then it also leaves the toxins in place, such as ammonia. A lot of studies have been done, but a recent Cochrane review in 2015, it showed that there is no differences in outcomes between the two culture systems. And this conclusion is supported by many other systematic reviews. If you look at the blastocyst transfer, I would not go into the advantages and disadvantages of a blastocyst transfer. The thing which is important is that if you are starting a new lab, if you are designing a new embryo culture system, then you should go slowly to blastocyst transfer. You don't open a lab and the first case, you don't think of a blastocyst transfer. You have to standardize the lab. You have to see that what suits your lab the best and slowly graduate to blastocyst transfer. It's a process. It's not a one-day job. If you look at humidified versus dry incubator, recent studies have shown that dry incubator conditions result in osmolality change over time. And an oil overlay is not sufficient to protect against osmolality changes during dry incubation. Effects on osmolality in non-humidified in culture may be less deleterious in culture systems with regular medium renewal. Or if you are using humidified conditions, then maybe you don't even need to renew the media because there is hardly any change in osmolality. Specific culture conditions such as oil volume depth, medium surface area to oil interface, ratio of oil to media, room humidity, pre-humidification of oil, a medium droplet size, as well as medium changes can affect the results. I'll come to these points in a few slides from now. Now, this was the dish, the open dish in which, open culture dish in which Edwards cultured in 1981, till 1981 rather. Evaporation is much greater in open culture and chances of contamination of microorganism is high. The high volume of medium used may dilute metabolites and paracrine and autocrine factors. And there's a lot of pH change which is observed due to loss of CO2. So we came up with the new with droplet cultures under oil, in which 10 to 50 microliter droplets of medium are prepared and they are overlaid with oil. It prevents the rapid effusion of carbon dioxide gas from the media, preventing the better control of pH, eliminates the loss of embryos during handling, minimizes microbial contamination, preservation of autocrine and paracrine factors. It also absorbs toxins as well as VOCs. VOCs tend to partition in the oil phase and at a much higher concentration in the oil, but also because the volume of the oil phase in this kind of a dish is so much greater than the volume of the aqueous phase. So they are able to, so the VOCs are more greatly diluted in the oil phase and they are able to dissolve into the media also. But if you look at another kind of dish, which is one on your right, I'm not sure whether you can see the mouse. In the typical culture dishes, the surface area of the exposed oil is large compared to the depth of the oil, favoring dissolution of atmospheric VOCs into the oil more rapidly. Look at the dishes on the left. They can lead to dissolution of VOCs into the oil, whereas on the dishes on the right, there's a deep column of oil over a small drop of media, like a drop of medium in the bottom of the culture tube, the relatively tall column of oil covering the drop. Then the surface area of the exposed oil is small compared with the depth, and this is likely to favor the dissolution of VOCs in the oil. It's less likely to favor, sorry. So in these kind of dishes, there is less chance of dissolution of VOCs. So layer the dishes with the maximum amount of oil you can. Single versus group embryo culture. In this, again, the only concept is the in group culture. You have the autocrine and paracrine factors stimulating the growth of the sibling embryos. Microdrop culture. In this, the embryo density, if you talk about the embryo density, the optimal density is still not known. Gardner in 1993, he said that 20 microliter of synthetic oviduct fluid medium contains minimum energy supply for one embryo over a period of 6 days. And in 2004, he said that 50 microliter drops for 4 human or domesticated animal is the minimum requirement, and with renewal occurring every 48 hours. But the optimal density is still not known. Jafar Ali has shown 2 to 3 microliter, and he is culturing 2 to 3 embryos in that small drops. And honestly, even I've tried it, and we do get good blastocysts in the end. So it's difficult to say what is the optimal density for the embryos. The last topic, I think, for the day, this is the incubator type, box versus benchtop, because this is a very important part of culture conditions. Embryo development in vitro is increased by restricting the opening of an incubator using an IR sensor, and incubators with a greatly reduced working volume, successful allocation of one chamber to just 1 or 2 patients, using incubators with multiple chambers. Traditionally, big box incubators, they circulate room air through the incubator chamber and regulate the gas levels by the addition of CO2 and nitrogen. Clearly, this type of incubator is susceptible to the inclusion of those VOCs that are in the room air, because a lot of ambient air also comes in. That is why it is so important to control the lab environment. In contrast, modern benchtop incubators, they flush the incubator chambers with gases provided in cylinders, either pre-mixed or mixed inside the benchtop, and any ambient room air is flushed out of the incubator, preventing the VOCs from impacting the embryonic development. These incubators also allow for a direct flow of pre-mixed gases and minimal changes in pH, and faster recovery also. Another thing which is important is the incubator management. It is imperative to have sufficient number of incubators to match the caseload, and the number of times incubator opening should be kept to a minimum. It is advisable to have separate incubators for media incubation and embryo culture. Also, it is a very good idea to have benchtop incubators which quickly recover from manipulations such as denuding and ICSI. In the end, I would like to conclude that attention to detail and adherence to protocols in QC are absolutely vital for optimum results. Ivf Culture Media is an integral part of embryo culture system, which is a very broad and complex system, and its use must be optimized in every lab, and things which are working optimally in one lab may not work in your lab. So you have to sit down and study and standardize your lab. pH, temperature, osmolality must be carefully monitored and maintained. Choice and use of oil is critical. Consumables and equipment should be of the highest quality and should be tested regularly. And in the end, I would like to say that the person who is using and maintaining the embryo culture system should be adequately trained and should be good in his works, because embryo handling is almost 50% of your results. With this, I end. Thank you so much.
Thank you, Dr. Sarapres, for very elaborative and very descriptive information about culture system. Being an embryologist, it is always our basic requirement to understand the culture system so that we can produce a better quality, good quality embryos, which results in pregnancies. So now with this, we will move to our panel discussion, and I would like to invite Dr. Shukla and Dr. Krishna to moderate the panel. A little brief introduction about Dr. Shukla. He is presently lab director at Baheti Hospital, Jaipur. And other than that, what I can say is he is a very well-known personality, because the slide is not in front of me yet. Now he has done his PhD doctorate in life sciences, and he has worked on early diagnosis of typhoid fever, working in field of human reproduction since '98, and since 98 only we are very good friends, and he has done his fellowship in 2006 in biology of reproduction from Centro de Estudios and Gynecologia Reproduction, Buenos Aires, Argentina. He is presently Secretary, Academy of Clinical Embryologists, India, and Chairman, Academic Wing, Academy of Clinical Embryologists, India. And he is also editor for newsletter of Academy of Clinical Embryologists, India. Now, I would like to introduce our second moderator, Dr. Krishna. He is now very well young, known embryologist to everyone, and day by day his work and his work is recognized. So his current position is Scientific Director at Oasis Center for Reproductive Medicine, Hyderabad. He has done Masters in Clinical Embryology from Monash University, Australia in 2008. He is a postgraduate diploma in reproductive sciences from Monash University in 2007. He has done his medical graduation from Rajiv Gandhi University, Bangalore in 2005. And at Oasis, his main areas of work are cryobiology, in vitro maturation of oocyte, andrology. Currently, he is working on employing newer techniques to improve the rates of in vitro fertilization in PCOD and recurrent IVF failure. So, welcome Dr. Shukla and Dr. Krishna. Now, I will hand it over to you. They will introduce the panelists.
Thank you, Dr. Charu, for that kind introduction. So, Dr. Sanjay, do you want to take the lead?
Thank you, Krishna, and thank you, Dr. Charudat. Friends, we have invited Dr. Jayanji Mehta, who is one of the renowned person in the field of embryology and who is a UK-based embryologist nowadays. Unfortunately, he is down with COVID and not feeling well, so he apologized that I may not be able to participate in the webinar. It's a loss that we are not able to hear his expert views, but had he been here, he's one of the pioneers in the field as far as the Indian embryology is concerned. He is also a member of HFEA, licensed center panel. So he is one of the guys who issue the license to the practicing embryologists. He is also responsible for several turnkey projects in 6 continents, published extensively. Everyone knows that. And he has also edited 2 books. He is also involved with some of the books that is being published by IFS nowadays. And he is also awarded Lifetime Achievement for his contribution to the field of embryology by IFS in 2019. Next speaker, next panelist is our good friend Sudesh Kamath. Again, nobody requires his introduction. He is one of the stalwarts in the Indian scenario. More than 25 years experience in human embryology. He is Mumbai based, but he visits all over the globe, I believe. He is past chairman embryology SR for last 2 years, that is from 2018 to 2020. He is MSR committee member. He had received ISR Lifetime Achievement Award for embryology. Also ET Health World All India National Embryology Icon Award, gold category, part of the team responsible for first ICSI baby of India, first ICSI baby of Nepal, first ICSI baby of Rwanda, first assisted hatching baby of India, and many more. I mean, probably is very humble to mention only a few things. Worked on human spermatozoa at the electron microscopy level, and as he is well known for his ICSI skills, he has injected more than 300,000 oocytes till date and counting. So welcome, Sudesh.
Thank you, Dr.
Over
Shukla.
to Krishna.
Honor of introducing Dr. Sujata. Indeed, a very, very humble and a great teacher. I think whoever starts their journey, I think at some point or the other, cross Madam, and she's always humble enough to share her knowledge, ever encouraging. Really looking forward, Madam, to learn more from you from this panel. I think she always surprises us with a lot of things. She's right now holding the position of Head of Embryology, NOVA Ivf Fertility India. She's done a PhD in biochemistry and molecular biology from University of Mysore, and she's the only proud holder of the American Board of Bioanalysis certification in embryology as a lab director. Madam, such an honor to have you in this panel. Looking forward to learn more from you.
Thank you very much, Krishna.
Joining all the panelists is Mr. Gaurav Kant, ever energetic, young, bubbling with energy, and lots to learn. So much of troubleshooting, and just comes up with easy ways of doing it. So right now, Dr. Gaurav Kant is the senior embryologist at Akanksha IVF. He's been the first embryologist to be certified by the prestigious societies ASRM and ESHRE, and he is, to his credit, a lot of presentations, abstracts at these international conferences. It's an honor and pleasure to have you in this panel, Gaurav. Welcome. So welcome to all the panelists. So we will quickly go through the questions. So for all the delegates and audience who've joined us this evening, Saturday evening, precious time, family time, and all of us are looking forward to learn from these eminent embryologists in the country. So what we thought, rather than just having some topics to discuss, we thought it would be best to have clinical scenarios, day-to-day clinical scenarios, which most of us face in the laboratory. We thought it would be very, very practical to have these kind of scenarios where all our experts in the panel here today would help us with knowledge, information, and make it easy to solve these problems. So can I request to have the scenarios? Sanjay sir, can we have that?
Sure.
Please. So we're going to be dealing with all the controversies and consensus. So we're not really going through every detail in this. I think Dr. Sarpreet really took us through the entire scenario, touched upon those little crisp information which are pertinent for our practice in a day-to-day laboratory. I always love this little picture. I think embryo culture system isn't just one step. It isn't about picking the sperm, egg, and making an embryo. There's so much more that goes in, and that's what makes it quite complex. And sometimes when just people ask those one-liner questions, I didn't get this, what do? I wish I had the answer for that. So here is my expert panel who's going to take us through these various difficult scenarios, challenges that we undergo in our day-to-day practice. So the first question, since Dr. Jayant couldn't join us, Dr. Sarpreet has really taken the pain and accepted to be a part of this panel. Thank you so much, Dr. Sarpreet. So I think the first question, I think it would be best if you can take it, because it's more pertinent to the Delhi area or any of the metropolitan areas in the present scenario. So this is a newly constructed lab in New Delhi. It hasn't had a single pregnancy in the first 3 months. Proper validation was all done, and now they think nothing is coming, and they're getting very concerned, and they're approached our expert panel today here, along with Sarpreet. Any of my team there has got any additions, that'll be great. Their DOP test failed. Their particle count for the 5-micron filter was reading 22,000 particles. The VOC levels, when they checked, was quite an alarming thing. It was just a qualitative meter, and it was showing a red alarm. But the remaining aspects, that was the equipment validation, and the ceiling, the flooring, or walls, all of that was scientifically done. So with this particle count failing and the pregnancy not coming, how can you help this new lab get on to normalcy?
I would like to ask you whether the burning in was done properly. I mean,
yes, it was done, but the particle count was done, initially had passed, but later when this 3 months problem came, when we repeated the particle count, it was surprising to see that the 5 micron filter reading was not passing. It was quite high. The VOCs were also
during
high.
erased or was it during the operation? I mean, what this reading was during erased? I mean,
Yes, it was taken in the morning after 10 to 12 hours of resting of the lab.
So then it is critical. Then you have to actually see from where so many particles are coming. There's the more important, I think, the VOC levels. The qualitative machine is showing a red light. So
Okay.
I think VOC is affect embryo culture conditions much more grievously compared to enhanced particle counts.
Okay, so I think the first thing, all of us have this question with us. I'm sure I go to a conference and I come back with this enlightenment that air handling unit with a VOC filter with multiple other pre-filters, HEPA filters, giving me a positive airflow system. This is the best thing to do. But when I come back, in reality, when I'm sitting with my clinician and saying this is how it should be, in reality it might not, for various reasons. And then there are times where they say, why don't you get a little filter that can sit in the one of the corner of the lab? In a situation like this, what would be the take to all my panelists there is, should all of us be looking at a centralized air handling unit? When we are all doing in vitro work, is there a standard practice?
See, we have been using air handling units, and in my experience, I feel that if you have a good engineering support, then AHUs work much better because you need round-the-clock support for AHUs, and they need to be constantly monitored for pressure as well as humidity as well as temperature.
But
Whereas,
would these towers do equally good job as centralized air handling units?
Krishna, can I start? Can I
Yes,
add something?
absolutely, sir. Please.
Yeah, but before I begin, I'd just like to thank, Dr. Ved Prakash and IHRA for this opportunity to be here on this panel, and all my fellow panelist moderators. Before I just come to the previous slide, where you mentioned particulate count more than 22,000, DOP test failed. What I think basically there is a problem with the HEPA filter.
Yes.
So that is what, of course, it's just a 3 months lab, newly set up lab. So basically, first thing you catch hold of those guys. Why is the DOP test failing? That means your HEPA filter is defective. That is what is my opinion.
Wonderful.
Annual particulate count, so we have to check that, which should not happen in a newly constructed lab.
Yeah.
VOC levels also very high. Of course, HEPA filters can't stop the VOC, but it's like basically the lab is not done up properly. So basically some problem is there, especially the HEPA filtration system.
filter
Yeah.
quality has to be
Yeah, I think there's so many times this is frequently seen in newer setups. So many newer setups coming in the country, and there's so many times not so senior embryologists joining these centers, and there's a lot of panic button going on there. And I thought it would be the best scenario to discuss and get inputs from all the expert panelists here, because this is how things are starting. People take some time to settle down, and usually the air quality is a bigger challenge with so much of pollution going up in the metropolitan cities and the bigger cities, and not much thought that goes into air quality. There are so many times where we see small little units, or sometimes just a split AC being kept in the laboratory, and people are assuming air handling is being taken care of just because they're restricting the people's entry and exit from the lab. So, Dr. Sujata, Dr. Kamath, your inputs about the air quality. These are the questions that usually come to us. What to look for. When I'm saying air quality in the laboratory, what is the ideal air quality?
Krishna, can I answer this?
Yeah, please.
See, as Dr. Sudesh said, okay, there is some issue with the HEPA filter. Okay, that means the particle count is high. Now we are also seeing an increase in VOC. See, this VOC can either be from the newly constructed lab or could be from the new equipments which are there inside the lab. it's very well known that a new incubator is much more dangerous than an incubator which is being used for a very long time. So this BOC, and especially with no pregnancies for so long, it is something which is affecting the embryo in its immediate environment more than the room air. So I would also look at the, the equipments where they cleaned well, where they, like turned on for some time before they were actually used. And did you do a sperm toxicity test there? If possible, if you can get any frozen embryos from somewhere, that's what we normally do in our centers. We try to get some frozen embryos and then try to grow them in the lab before we even start the actual cases. So we have to look at the macro environment, and we also need to look at the micro environment before we start cases.
Wonderful. That's a wonderful analogy out there, madam. So if let's just specifically look at air quality. So whether it's a new lab or an old lab, when we're saying ideal air quality inside the laboratory, what is it? What is this definition of ideal for us in an Indian scenario for all the embryologists out there? How do you say this is the ideal air quality where you are going to get optimal culture conditions? Anybody could take that. Dr. Sarpreet.
Because Dr. Sarpreet showed us a beautiful slide.
Yes.
About air quality, how many particles. So I think he can just, mention about.
So are we only looking at particles and VOCs if at all we do the particle count and our particle counts are less and it's passing the test and our VOCs are within a permissible limit? Are we good to say that the lab's air quality is good and we could continue and look into the other aspects?
I think that would be sufficient as per my opinion.
And a tower or a centralized unit, both would give us a similar kind of management of air?
As per the ICMR guidelines, you have to have an air handling unit. The AC should come through the AHU. So many centers also have a CODA tower and all. But it is recommended to have air handling units, especially in a place like Mumbai where we work. We have small places. So the air handling unit is on the ceiling. It doesn't, the CODA towers and all take up space. So there are sometimes, CODA towers, they also, some of them, they can take out more particles and all, but just a central air handling unit is more than sufficient.
That's wonderful. So how frequently do we need to do this particle count? Once a year or every month or once a quarter? What should be the schedule of doing an air quality test?
We don't do it so often. If everything is going fine, we are getting good embryos, good blastocysts, we do it only once in 6 months. And for that, we have a professional team. We don't do all that. We have annual maintenance contract. So depending on how is the contract, whether once in 3 months or once in 6 months. But I think if everything is fine, once in 6 months is a must.
Wonderful. Wonderful.
I think it more depends on the location of your lab. If you are located in a very busy place, where there is a lot of traffic and where there is a lot of pollution, then, you have to look for these parameters frequently, at least once in 3 months. But if you are in a residential area and where you do not have much of pollution, then I think even once in a year is fine. But then this is the standard procedure. But whenever there is an issue, I think you have to look for these parameters.
It's mandatory every time you change the filter. So then the change of filter also depends on your location, like Dr. Sujata said.
But we should be looking at a change of filter at least once a year, and the particle count at least to be done once a year, if required, at least twice or thrice a year on need basis. And there's so much that we talk about VOCs and the limits and all of that. So have we come to a point where we say VOC filter is a must of our air handling unit? Earlier, we only used to have the HEPA filters. Now I think there's so much that has been changed in terms of engineering and AHU itself. So is it mandatory to have a VOC filter?
Yes, it is.
So all my panelists agree on the fact that VOC filter is a must in an air handling unit.
If you have it, it is better. But even if you don't have it, you take precautions, like you don't handle all the volatile compounds inside. Of course, now in COVID times, I don't know, because all sanitizers and also it's a must, preferably now in present scenario.
Yeah. So can we have the next slide, please? So this was this wonderful consensus done in Cairo, came up in 2018-19, which wonderfully puts across the consensus and guidelines for good practice when it comes to the air handling unit, air quality, the VOCs, and the little micro environmental culture conditions. So to all our audience out there, if you have not really come across this paper, it's for free download, available in PubMed. Please feel free to read. And I think there are a lot of points for good practice. So we go on to our next question. So Dr. Sanjay, if you could just take this question for us, please.
Okay, so our next scenario is like we have an IVF lab in Vizag, which is a coastal area, and suddenly starts having condensation on the lens of ICSI microscope. The staff in the lab starts feeling very uncomfortable. The relative humidity on the hygrometer showed 95%. Decreasing the AHU temperature to 18 degrees did not help. So how do we proceed in this situation? The similar question is asked in the question box also by someone. So I think probably this discussion would answer the questions of the audience also and the questions that we put across. So I would like to ask this question to Gaurakant, please.
Thank you so much, sir, for the question. So looking at this, first of all, I want to talk about humidity itself. So humidity, if you talk about the humidity, how it impacts the lab. Okay. So what are the management and what actually happens suddenly? So if we look at the impact of the humidity, it actually forms the molds inside. You can have the fungal growth. You can have the corrosion on the instruments. You can have the short circuit of the incubators or the wirings nearby. So for that, you should have a controlled humidity of 40 to 60%, right? So you should, to maintain it, you should have a management. If you look at the management, if I'm sitting here in Delhi, so where the humidity is high in generally 2 or 3 months, and that is not too high, desiccator is enough. But if I'm sitting there in Vizag, where the humidity is very high, then you should have the HVAC systems. So when people are buying HVAC system, they should be aware that the HVAC system should always have a dehumidifier with it. So people buy the HVAC system without the dehumidifier sometimes. So in this question, if you see that suddenly something has happened, suddenly. So if we say suddenly, that could be because the humidifier is not working. And the second wrong thing which the person has done is decrease the humidity temperature to 18 degrees Celsius. So reducing the temperature is not a solution to control the humidity. Even if you increase the temperature to 10 degrees Celsius, it releases or reduces the humidity to factor of 2. Means if you have a 95% humidity at 18 and you increase the temperature to 28, you probably have a lower humidity at that point. So the first thing the person should do is slightly increase the temperature to around 25, 26, which is actually reasonable, and look at the dehumidifier, whether that dehumidifier is working or not.
Okay. So there are some standalone dehumidifiers also available.
Can I just add something?
Absolutely.
Yeah, regarding now, Gaurav has nicely explained. So basically, there's something wrong with the AHU. And even I have faced it, when I go to Delhi sometimes in summers, we do have this problem. But, your next line question you mentioned, how do you go ahead? See, you can't stop your IVF. It becomes really very uncomfortable.
Exactly.
So this is what I just mentioned. One thing which Dr. Krishna he had just said it before. I always recommend, have your regular standalone split ACs also. It's a must. Don't use it. You use your regular AHU. But in such times, you have a dehumidifier, but have a regular standalone AC. That will solve your problem because most of the humidity is, absorbed by the air conditioning. Otherwise, very, very difficult to proceed, to work in such conditions. You are very uncomfortable. You are sweating, and all this will increase your chances of contamination.
Sir, but the HVAC which is already installed is going to control the temperature. Split AC, yes. Additional split AC, how will that help?
See, that is here as per the scenario it shows your AHU is not working. You're bringing the temperature down, and I have faced such problems. Not just in Delhi, other centers. So we have fitted split AC. It brings the temperature down, and there are inbuilt mechanisms, in the AC. Nowadays, you got even plasma filter ACs and all, which will absorb all the humidity. That brings it down. Temperature also cools down. And see, if your temperature goes up, it's very humid. Your system, your incubators and all can pump off any time.
Yes.
You have to see that.
Yeah. And Dr. Sudesh, would it also do something to do with the number of times we are opening the door, or there is some amount of leakage of air or temperature from the OT to the laboratory? Would
that is the second thing what I was going to come about. See, now these whatever IVF lab, it has to be a sealed unit.
Okay.
So air, many times the OT is just next. We all of us have a OT next to the lab. There is a window also. If that, and you mentioned Vizag, it must be very hot, humid. Even the outside air is coming, all hot air is coming in. So even this, the outlet is a small window. From there, the air comes in. That can also increase the humidity. Even that's why double doors and all are recommended to bring down the humidity inside.
Wonderful. So for all the audience out there, if there are any questions, you could keep posting it to our panelists out there. So I think a relative humidity of 40 to 60 is what has to be maintained. Anything which really goes beyond that, there's going to be a lot of human fatigue, and that is a potential threat for molds and fungal growth, and that's going to affect our cultures. Now, anything really lesser than that might affect the osmolarity in the culture system for us to an extent. So that was wonderful inputs given by this. Since we were talking about humidity, few other microculture environment things which we probably don't stress so much. We put in so much of our mind into incubator, media, and air quality. But coming to light, every time I go to different labs, there's some people who say, I just don't care what the light is. We have had wonderful results. And there's some people who are so obsessed where they only keep very dim light. It sounds nice, but I found difficulty working in such labs because I start grouping for the dishes. I'm more scared that I would actually mismatch something in a dim lit lab. So what is your take on the light? What should be the permissible light, and how should we go about with it?
Krishna, can I answer this?
Yes, ma'am. Yes, please.
So see, the thing is, the idea of having a minimal light is because the embryos are never exposed to bright light. So in every possible way, we are trying to mimic a in vivo system. That's the idea. But then, as you rightly pointed out, when you are taking the dish out or when you are labeling the dishes, definitely you should have a very convenient lighting. Otherwise, you're bound to mix up samples or you're bound to mix up embryos. So what is recommended is to have an adjustable light in the lab. So whenever the embryos are exposed, you can reduce it. And whenever you're doing your paperwork or you're, labeling or moving from one dish to another, you should have a light in which you are comfortable.
Wonderful. So
here I would just like to see, even we try to use minimal light, but of course not complete dark. But the funny part is whenever we are doing all our culture, say stereozoom, microscopic, see, aren't the embryos exposed to the maximum light? What can we do about it? And still we get good embryos.
Yeah.
I think Dr. Shukla, maybe you are having a smile, you can add something.
Yeah,
we are thinking about outside, we have to dim it and all, but what about the own microscopic light where all the oocytes, embryos are exposed continuously? What can we do about that?
See, certain components of culture media are light sensitive. Okay, it was shown that like a piece buffer is shown to be sensitive to light, and that was one of the main reasons why it was said not to expose these media to light. And you're also looking at the UV part of it. If you're looking at fluorescent light, then you have a UV radiation and you want to avoid that also. What we see in the microscope, definitely, microscope lights are brighter, but then we also have filters.
Wonderful.
Okay, and then it kind of protects our embryos from the harsh light.
So
and
whenever possible, madam, so we will take that point that, trying and avoiding a prolonged exposure to the gametes and embryos is something that we need to look at and minimize brighter lights, especially the UV. When we're looking at the spectrum of lights, I think 450 to 480 nanometers is what is the permissible limit. Similarly, sound, do we really have to have acoustics, or it's okay to have sound? Would it really affect the embryonic culture system? Is it an essential element in the culture system?
I don't think so because at least we do not have much of information on that. But I see many labs where they have music during the procedures, and even there was a study in EV, I think, or in one of the Spanish labs where they had put a system inside the incubator and they found a better outcome with music. So
So
I
no
don't think
consensus on
yes,
that point.
yes.
So
I think
But the
humidity.
thing is, we don't have evidence.
Yeah.
the sound what we like to avoid is, the mobile sound inside your lab. So in our lab, strictly no mobiles are allowed in the IVF lab. We
A
leave it
very good
outside.
point, Dr. Sudesh. I think a lot of the younger generation, there's so much of distraction. So many times I also see that the moment a WhatsApp or a Facebook notification comes, irrespective of what they're doing, their attention is diverted. So I think mobile is the biggest distraction of the present generation.
Not just the distraction, but mobiles are the uh,
Radiations.
biggest, yeah. So radiations, electromagnetic waves, and they are the biggest source of contamination.
Yes, yes.
So in COVID times, in fact, it is essential to put your mobiles away from the laboratory.
Wonderful.
What about the witnessing systems which are based on, you need the Wi-Fi and a strong Wi-Fi all around your lab? What about the effective radiations in those cases?
Well, I think that is what is to be studied.
I invite Saraprit to have a study on this.
Wonderful. So we'll just continue because we've got 6 more scenarios to finish.
Correct.
Quick one-line answers for temperature inside the laboratory. What is the ideal room temperature, if one of you could just help us with that?
23 to 25 degrees Celsius.
23 to 24.
Wonderful. So anything, can we put it from 23 to 29, or 29 would be a pretty higher side?
No, that would be very difficult to work with. 23 to 25 is ideal.
Okay, wonderful.
If
Sanjay.
you raise the temperature, you are also increasing the VOC.
Yes, because we are sweating inside the laboratory.
Yes. So
and the human fatigue is going, I'm sure by midday we are exhausted because of the hotter temperature. Wonderful. And a quick thing about the voltage. I've had a personal experience where I looked in every little aspect and never really bothered about the voltage bit of it, because I was sure the electrical people or the engineering department would look into it. And they said all okay, and we started the Hericel, we switched it on, and that's it. We had a short circuit. The whole motherboard first day was burnt. And then we realized that there was some backfiring of the voltage from the transformer, which is too technical for me to understand. And that is the day I understood that when I'm setting up a new lab, it's just not about the backups that I'm looking at, but also look at the voltage and see whether my equipment can actually hold that. So any learning points for us on voltage from all the expert panels?
The surge protectors should be installed actually, because every time there is a power cut and the light kind of is reinstalled, there is a surge in voltage which damages your speakers and incubators. I mean, it can
especially in an Indian scenario, I think this is going to be a problem. I might do a lot with my lab, but when it comes to electricity, I think I'm going to the transformer, which is given by the electricity department. So a surge protector is a wonderful
we also
input.
Do have voltage stabilizers. I'll just like to add one thing. We have different equipments. We have different voltage stabilizers. Like if I have 2 incubators, I have 2 different voltage stabilizers, and none of them, are connected to the Laminar Airflow. That is totally separate. So even if there's some problem in one voltage stabilizer, some problem happens, at least your other incubator is safe.
Absolutely. Thank you. That's wonderful. One last thing in microenvironment: air curtains or air showers. I see some of the sophisticated labs where you're made to stand for 30 seconds, take a shower, then go inside after you've scrubbed yourself. And there's so many labs which can't afford and don't want to do that, but equally are giving good pregnancy outcomes. So from all the seniors out there, do we really recommend a routine use of air curtain showers before we enter the laboratory?
I think now in COVID scenario, yes.
Okay. But in a general scenario, Dr. Sujata, would this improve the outcomes?
No, the thing is, it just gives an additional protection. Okay, but then it's not mandatory. And definitely it will be helpful in cases where the embryology laboratory is in one level and the andrology laboratory is in another level. and the embryologists are running between these two labs. And sometimes what happens, they do not change. They just only change their, outer,
Lab gowns, yeah, lab coats.
So in those cases, definitely this is helpful because, this is an extra level of protection.
So thank you so much for those expertise. Let's go on to the next scenario. Dr. Sujata, if you could help us with this scenario. So in one of the busy mornings where there are a lot of OPUs, vitrifications lights are lined up, suddenly there's a circuit breakdown of electricity. The laminar airflow is burnt now. So this neither the heater on the laminar flow nor the stereozoom microscope is switching on. But good thing is the incubators are still on the UPS and generator, and we are able to run it. So now there's a lot. First thing, I think as an embryologist, if I'm in a situation like this, I would panic. So please help us. How do I actually go ahead if a situation like this?
I know this is a nightmarish situation, but the first thing to do is not to panic. Okay. Because when you start panicking, then you are bound to do more and more mistakes. But just, compose yourself. First thing, check if it is localized to one particular plug socket. Okay, even if your microscope is inside the laminar airflow, try to remove the plug of the stereozoom microscope and plug it in another power source. It should work. In case if it doesn't work, it might mean that the bulb has gone because of this, excessive power which has come. So change the microscope bulb and it will work. Now, so the microscope is okay. The issue is temperature maintenance on the laminar airflow, because anyway laminar airflow doesn't work. So what you can do is see if you have any movable stage warmer in your lab, like the Lincoln stage, which is on the ICSI microscope. See if you can, if you have something like that, you can remove that and put it on your laminar airflow. Or if you have smaller incubators or even a Hiracell, a box incubator, you can remove one of the shelves and then keep it on the laminar airflow stage for some time, at least, like for the next 5 to 7 minutes. It will help you to maintain the temperature from 37 to say 35 or 33 degrees Celsius. Now turn the air condition off, turn anything in the room which actually would bring down the temperature, and handle one, because you are getting ready for a pickup. So if the pickup starts, then you just handle one tube at a time. Okay, don't pour everything simultaneously. And another thing what I also would like to do is, don't expose your petri dish directly onto your laminar airflow stage. Instead, keep it on a lid. So sometimes it will just help you to maintain the temperature. So with this, you can finish the procedure.
Wonderful, ma'am.
Can I just add something?
Yes, sir, please.
Yeah. Regarding your stereozoom micro, supposing you don't have a spare bulb, it always happens, such when your light goes off and many times you don't have. So you can even take a torch, and fit it near the where the bulb is. That can, because I have done that in one place in case where in the ICSI, I done ICSI with a torch and it did work very well.
Wonderful. So
If you remember, Sudesh,
Pardon?
If you remember, we did this thing 25 years together.
Yeah, the old memories.
Yes. So that is why we brought in the best panel today. As APJ Abdul Kalam says, one good friend is better than a library of books. So having one senior person, I think the experience talks. And for me, I think it was a wonderful input. One is using the torch, and second is using the plates of the Hiracell. I had never thought of it. I think that's a wonderful troubleshoot, Sujata ma'am. I'm sure a lot of juniors out there are loving this discussion.
Yeah, Krishna, another related question I would like to ask to Sudesh. Do you have any recommendations to the juniors when they are changing the bulb? How to change the bulb?
Actually, it's not difficult. It's very simple. Anyone can, change the bulb, either of the stereo zoom or even of the micro manipulator. What is more important, having a spare bulb.
Yeah, so that is
very, very important.
Important. So the take-home message is that you always keep the spares.
Yeah.
Can we go to the next slide, sir?
Yes, please. So we move on to the next scenario. Shall I take this one?
Absolutely, sir, please.
Okay. So in this scenario, one of the IVF centers in an urban area offering around 120 cycles per year has 2 benchtop incubators. There are 3 dishes in one of the incubators. One case was day 1, one was day 3, and one was day 5. Day 1 fertilization check was concerning 6 out of 12 fertilized and 6 oocytes had degenerated. Day 3 dish and day 5 dish, all embryos arrested at 2 p.m. stage. Normally, the lab has good KPIs, but in this particular scenario, how would you troubleshoot now?
Should I take the question?
Please. Yes, please.
Yeah. See, basically, let us go step by step. First, you said day 1 FERT check is only 50% FERT. If it is ICSI, so maybe then half the oocytes have got damaged. Or many times it can be even when we do, if the oocytes are very fragile. So that we have to find out. It was IVF, so why would it degenerated? And maybe next day when you're doing a FERT check, you're clearing the cumulus, maybe that time it has happened. One thing about this, what I noticed, second day 3, day 5 dishes, all the embryos had arrested. So here, what I mean, why it was that day 5 was missed. Very, very important is to do FERT check. Not just for, checking fertilization, also to check if there is any contamination in your dish. Maybe if this was noticed earlier, there is a arrest in 2 p.m. on the day 5, it's on day 1, if you had seen it. Maybe then you could have taken, you could have done something like change the media. Media is one thing which can arrest. Then you check whether there has been any contamination. Because even day 3, you are seeing there is an arrest. And day 5, there is a degeneration. So whether the arrest is because the embryos have got degenerated, it's totally a contamination. And then other thing what I will advise is not to keep all the dishes in one incubator. Ideally, what we do, even if you have say 2 oocytes, we have at least minimum 2 incubators. Put one dish in one incubator, other in the other incubator. And what we do, not many of them do it, we always for every patient, we order 2 different medias. So ideally we put one oocyte in one media, other one in the other media. It is slightly more expensive, but then you can't blame the media and all. Okay, media is at fault, but this thing, what are you going to do about it? So this is how we take care.
Wonderful. Anybody? Thank you so much, Dr. Sudesh. Any other panelists would want to throw some light as to, okay, why did the day 3, day 5 dish have a 2 p.m. arrest? Apart from contamination, what are we thinking of in terms of troubleshoot here?
So what I remember from my studies is basically the 2 p.m. arrest is basically because of the EDTA, when the EDTA was not there in the media. Okay. So initially that used to happen, but that being rectified and the new media has EDTA. So there are no 2 cell blocks or the 2 p.m. blocks nowadays.
All right. So it has something to do with, it could have been that this particular bottle of media did have a concern, and that is where we probably had some degeneration and a 2 p.m. arrest. So it's contamination, it's then the media's pH, osmolality, and could the temperature fluctuation in the incubator could that be one of the reasons?
That could also be, the incubator can also be one of the reasons. If the temperature changes, and many times, the temperature inside and what is displayed on the sensor, sometimes there is, lot of difference. So what we do take all precautions, even a small thermometer, we keep it inside. Okay. But what is, like I mentioned, why the day 5 was not seen? Every day you have to check. This can happen,
I think nowadays with the single step coming into the picture, there are people getting into the system of an uninterrupted culture. And that is where probably, I'm assuming that is why after a FERT check, it wasn't opened and seen. So that could have been one of it. But Dr. Sarabjit, you had something to add.
It can be either a temperature issue or there is something wrong with the maybe gas.
Okay. So the gas mixture could have been very, I think when things are going wrong, we are always lost with the incubator and the media. We don't really seem to be looking at the gas cylinders, the quality of the gas and things around the gas. So I think, Sanjay sir, if we can have the PPTs, I think pertaining to this case, there were a few more questions that we wanted your inputs. And I think the fundamental question is how much of incubators is needed. Let's say this is a 120 cycle per year, which is meaning that probably every month there are 5 to 10 cases being done. So in a small run lab like this, there's so many times the finance or the investor is saying just go with one incubator, one microscope. They really, there's a lot of pressure to cut cost. So for all the fellow colleagues out there, if you could throw some light out as to how do we plan our equipment inside the laboratory when we come up with a setup. Sujata ma'am or Gaurav, Sarpreet, anyone?
Can I add?
Yeah, please.
Yeah. When you start an IVF lab, even as per the ICMR guidelines which are modified, you need minimum 2 incubators. Even if you are doing, say, just 1 or 2 cycles a month, 2 incubators is a must.
Okay. So see, laminar airflow, of course, it's going to be one, but is it advisable to have a 6x2 laminar airflow with 2 stereozoom microscopes, or because it's a beginning lab and space is a constraint in most of the labs in India, so do we stick to a 4x2 with 1 stereozoom?
I'll prefer a 4x2, and I would, if we have more finance and bigger space, I'll prefer to have 2 laminar flows instead of having 1 large
one. 6x2, so that if there's an electrical shutdown, we could always look at it. So I think that brings us to the concept of having a critical kit or an emergency kit. So if I had to have a critical kit in my laboratory, can you please tell us what all goes into this kit so that I don't panic on a day-to-day basis?
You should have, I think, an extra ovum aspiration pump, number one. An extra injector for your ICSI machine.
Mm-hmm.
Like Dr. Sudesh said, that if you can manage to have a couple of 4x2s in place of a 6x2 with obviously 2 stereozoom microscopes, there's nothing like it.
Okay. Anything else, Sujata Madam or Sudesh sir, you would want to put it in your emergency toolkit?
We have backup for everything.
Okay.
Always spare we keep, especially the bulbs and all. See, certain things like the micro manipulator and all, you can't have more than 1. Unless you are OSS and all, you can have only.
So we also have only 1 micro manipulator.
Yeah, but small spare parts and all, like even Sarpreet mentioned, injectors. Those are also very important, So if you are doing a lot of cases, your injector breaks down, you are stuck. That also, we always have a spare injector.
Wonderful.
So that's it. I agree with all of them.
Wonderful. So the last question when it comes to that scenario out there, I think this is a constant thing which crosses all of our mind, calibrations and validations. There was a point where we thought yearly calibrations was fine. And now every case that goes wrong, there's a lot of pressure or that little blame game to say, oh, did you really check the pH again, the temperature again? I know being obsessive is a good trait for an embryologist, but where do we draw the line when it comes to calibrations? I think if you're talking about pH, temperature, because this is the main area of media, pH, temperature. These 3 things keep on popping up. The moment there is no blastocyst, no fertilization, the first question comes is, did you check with your media? Did you check with the temperature? So should we be doing it? How frequently?
Krishna, can I answer this?
Yes, ma'am.
So see, I'll just tell you our practice. Okay. Temperature is checked almost every day. Okay. So the thing is, like, if it's a box type of incubator, we have a calibrated thermometer inside the incubator. And similarly, we use a thermocouple. And with the thermocouple, actually, it just goes on a full circle in the entire week. One day we check the benchtop incubator, and that too, we just don't check in one place. It's kind of a temperature mapping. We just put it in one corner, and like it's specified on each day it is different. Similarly, we also check the laminar airflow temperature. We also check the ICSI system temperature.
So it would be a good idea to invest in a thermocouple,
definitely,
rather than hiring it or renting it out.
Yes, absolutely necessary. When you ask me, I think there should not be a lab without a thermocouple.
Okay. So when we talk about gadgets, what are the bare minimum gadgets you would recommend an embryologist to have in the lab?
for temperature, okay, thermocouple and few glass thermometers. You need to pop one inside your refrigerator, one in the test tube warmer where you are collecting oocytes, and in the box type of incubators. And for all your bench type of incubators, you need a thermocouple. And again, our practice is, to check the pH also. In fact, the earlier place where I was working, we didn't even have a single CO2 analyzer, but all our labs had pH meter. And we check pH for every batch of media and every cylinder we are changing. Okay. And then if this doesn't happen in 10 days, we just check a pH. So, like our culture, it was based only on pH, and we never used to check the carbon dioxide. Sometimes, you would be surprised to see the CO2 levels of my incubator to be at 7.2, So we go by pH. And so these two things are very, very essential.
Anybody else who would want to add to Dr. Sujata's, Dr. Sudesh, you keep going around so many places out there. And I'm sure you've seen labs sometimes do not really have this. And most of us are like that, where we are scared, probably scared to tell the management that, you don't have a pH meter, CO2 meter, thermocouple. I'm not going to do the case. So how do we as freelance embryologists face a situation like this?
I will agree with Sujata. We also have a logbook temperature we check every day. As far as pH is concerned, if there is some changes, because we use phenol red media. So if there are some changes in the color of the media, then we'll worry. And of course, we also have digital, nowadays you get small digital pH meters, which are equally good, but we don't check it that often. We may just check it once in 10 days or once in a month. And if we notice any change in the media, and there are, like you mentioned, because I go for batches, where we do batches, it's a different system because they all have AMCs and all. So before the batch starts, say 1 week before, the engineer will come from the company. They do the calibration, they'll do the temperature check, they'll do the CO2 check, everything they check before we go ahead.
So the take-home message for all our participants today is, you need to have backup plan for everything. They need to be frequently validated and calibrated. Done your SOPs, kept it aside, calibrated once, and you've left it. I don't think that really works well. Even the best lab will have a change in temperature, pH, osmolality, and all of that. So I think you need to look into the AMC's validations and backup strategy, right from the clinician embryologist to equipment. Backup is the thumb rule of an embryology lab or a well-run lab. So Dr. Gaurav, if you could just help us with this situation. Suddenly the junior has come to make the dishes in the evening when I have left, suddenly sees the bottle frozen. And now first is he's scared to call me. And second, he doesn't know what to do. What would be your recommendation in a situation like this?
So, Chaitanya, generally I give liberty to my junior embryologists that they can free to say anything, whatever they have done in the lab. If they have done any worst thing possible, they should inform me. I'm not going to hold them. I'm not going to throw them out of the lab, because knowing me what is happening in the lab is more important to me.
So the work culture really matters. Yeah, unless we create a congenial work environment, I don't think embryology practice works.
Yeah. And looking at this, if the media bottle is frozen, you should always have a backup of the media. First of all, if you don't have a backup, you should, if you don't have a backup, then you should call some nearby centers from where you can arrange the media. And now we have to see why that happened, basically. So this happened because of the temperature. What is the temperature there in the fridge? Generally, what happens when you put the media near to the freezer, where the temperature is less, then the media bottle freezes. So you should be careful where you are putting the media in the fridge. It should be maintained to 2 to 8 degrees Celsius.
So you would never recommend doing dishes, can I thaw this media, make a dish after checking pH or something if I can? Would that be recommended, or this bottle media has to be discarded?
See, if I look at the media, it has been frozen. Once, the first thing is the osmolality has changed right now. Okay. As you said, we have to thaw the complete media. We have to make it warm, then we can use it. If you want to use it for once only. And we really don't know what has happened to the proteins, the impact of the crystallization on the proteins, the amino acids, and the vitamins. So every single item.
Yes, madam.
There is calcium phosphate precipitation also. When you just freeze media, you immediately see this calcium phosphate precipitation. So,
Okay.
I don't think you can use
so
it.
the expert advises, please do not use a media if you're in a situation like that. Sir, if you could just go to the next slide, sir.
Yeah, so that would like the suboptimal conditions for the embryos if you do that.
Yes. So I think refrigerator is what is also an essential element. We are only talking about benchtop incubators, pH meter gadgets. I think a simple thing like a refrigerator not maintaining 2 to 8 degrees could be at a fundamental level itself taking things to a wronger this, and bigger troubleshoots might not really matter much. So we're running out of time. So let's go to the next scenario. Sir, if you could take the lead, please.
Okay, sure. Thank you. So our next scenario is in the lights of COVID. So post-COVID lockdown during the month of May, one of the IVF chain, which has 10 branches all over the country, and all branches started having similar concerns, that is poor blastulation rate and poor post-warming 2 hours expansion. They checked the air quality. There was no concern. It was perfect. The gas cylinders, yes, it was changed recently. Then pH of media was checked. It was 7.3. Temperature calibration was fine. Same batch of media in all branches. No deviations in SOPs. How do we go about this? Ma'am, probably this could be your scenario.
Yeah, the best person to answer this.
Okay. So the thing is, first is not to have a knee-jerk reaction. Okay, first point. 2, collect data. Like you have to see how many patients, like it could be in all the centers, but since you said it is post-COVID and none of us have started full-fledged, so we have to see it in how many patients has it happened. Okay, is it the data which is really like, which is worrisome? Now, the third point is, since you also said that it's affected all the labs, then that means that you can rule out center specific issues. Say you can rule out the contribution of embryologists, because all the embryologists cannot be doing something wrong at the same time. You can also rule out the culture conditions in the labs. Now pick up the common things like culture media, the consumables. Okay. So, and then it's good to have friends in the industry. You just, give this lot number and check with your friends how it has worked for them. Now, the second thing is find out when was this media ordered, because just before the COVID, we all panicked and bought a lot of culture media and we were, keeping it in the fridge. How was it stored? There could be nothing wrong with the media, but was it anything to do with our storage conditions? As Gaurav was telling, like if you keep it near the freezer or even if you keep it at the back of the fridge, it can cause temperature fluctuations and that can affect your culture media. Now, another thing which I would also look at is our SOP, because post-COVID, all of us have made changes to our SOP in terms of cleaning. Okay, so we have added extra steps for sterilizing things. Maybe we are overdoing it because, like in our SOP, we have mentioned that anything which comes inside the lab should be cleaned with a solution like safe. In some cases, we have said it has to be cleaned with 70% alcohol. So maybe because of that, we are overdoing it and then we are causing toxicity. And maybe that was the reason. So all
Wonderful.
These things I think I would look for.
Wonderful. I think what we really wanted to understand that, the cold chain, was it really affected? We really don't know at the distributor level, that whole transit from either Denmark or US to their factories, there could have been a lot of delays at the customs or in the transit, or we don't know how it was stored. And the moment we were all opening up labs in May and June, was the older media sent across? And was that one of the reasons? I think difficult to prove, difficult to blame, but I think you got to be a bit more extra vigilant with that. So I think wonderfully taken through, madam. There, the gist is really there. So when we've been talking so much about the cylinders and all. we really don't know if this cylinder is what the manufacturer is giving us as medical grade, because there isn't an authenticated certificate that comes along with this. And if you force them, they're sometimes giving us a printed thing on their letterhead, and I really don't know if that's authentic. So to all my panelists out there, how do I deal with the gas cylinder's purity? Sudesh sir, I think you've been there doing, and I'm sure things probably have changed in the current but 20 years back, whatever was there, you had to work with it, and you've done a wonderful job even at that point.
We get a medical grade CO2. You get medical grade, industrial grade. We ask for a medical grade, and we do get a certificate. We are not having any issues.
Okay. So in a situation like India, do you really recommend that every gas cylinder, before the gas is entering the incubator, should it have a carbon inline filter?
Yes, definitely.
That's a mandatory thing that, because, initially as a beginner, I thought incubator was enough. And then they said, put a connector. And now if I really go with certain manufacturers, even the incubators are coming with HEPA filters inbuilt in it. So I think the stress on air quality, bringing VOC down day by day is kind of coming up. I think that is what was the gist. Thank you so much, Dr. Sudesh, for putting some light out there. Can we go with the next scenario, sir? I think, there was a few more questions. I think we have touched few of the pH and the media thing. But one thing which I think it is my personal question to all the seniors out there, allocating of media. There's so many times we've had the smaller branches, which probably post-COVID, I've had only 3 cases done in that month, and a 20 ml bottle is opened up. What do we do? And if I could have allocated, probably I would have used it for a little longer. What is your take on allocating the media?
We always allocated, Krishna,
okay.
But always in that 6 ml tube,
okay.
and leaving very little headspace of air,
okay.
and allocating only with sterile under sterile conditions.
Okay. So
and
once you something,
yes.
Yeah, we are different. We never allocate media. We order smaller volume. Nowadays, you get even 10 ml volume.
Yes. So one situation that I personally experienced, I'm so sorry, I'm taking the names of the companies, nothing against anybody. We initially used to use Cook media, which used to be a 20 ml bottle. We used to allocate at that point and everything was fine. For some reason, we had to change to single step media. So we picked up Sage for some reason. That was a 10 ml bottle of Sage media. And then when we started allocating this 10 ml into 2 portions so that we could have used it, and that was our practice with Cook. So we suddenly started seeing the color change very dramatically. And then we spoke to the distributor. They said that, the Sage media, the bottle comes with a particular protection and we should not be allocating. We stopped allocating and the color change didn't happen. Now, I didn't find an evidence for this. Any of my seniors who've had any experience where allocating brought in issues?
Yes, I did have this thing. Once I was called by some center where I was not regularly going, and the same situation was there, what we described. It was like a sub-branch of a multi-branch chain. So there they allocated the media and sent it from a different city to this city. So I found that the fertilization rate and the embryo quality was not up to the mark. And then when I traced back, so I found that this was sent from somewhere else. So I never use allocating for media.
So I think take home message, can we put it in this frame that, you can allocate, but ensure there's absolutely no air gap, because air is going to change the pH. And as much as possible, order smaller volumes, because nowadays the vendors are giving us 10 ml bottles. And I think that would be, so this is where I think a lot of planning is essential. There's so many times where people probably are failing to plan, and that is where the whole thing is going. So the communication between the clinical team is very essential, and that probably would solve these kind of problems. So let's just go to the next question, sir.
Chaitanya, before we move on,
Yeah.
Another point, because someone has asked this in the question box, is that there are different expiry dates mentioned on the media. But again, I would like to emphasize here that even if you have a longer expiry or longer shelf life, once you open the bottle, it has to be consumed within a period of time which is recommended by the manufacturer, because those media are designed in a very different way. Although we are using for the same purpose, but every manufacturer has their own formulation and different ideas behind this. So we have to stick to the manufacturer's direction.
Wonderful. Thank you so much, sir, for that inputs out there. So the next scenario is,
I think culture oil we discussed already.
Yes.
So next scenario, please take on.
So again, one of the labs doing just a day 3 culture and an ET in a box incubator suddenly decides to go to a smaller benchtop incubator. So somebody's told them that this particular media would suit to a benchtop incubator, and they wanted to do a day 5 freeze ET, all of that. But that transition wasn't a smooth one, and the first 2 months their KPIs were all deviated. So what is your suggestion, inputs for all those people who are wanting to do this? Would really like to get inputs from you all.
So the first thing is, do not change two things simultaneously in the lab. That is, the rule of thumb. If you want to change your incubator, then don't change your media also simultaneously. First, try to do sibling oocyte or sibling embryo culture in both the incubators. Set your culture conditions right, because it's just not only the culture conditions, you also need to work on the size of the droplet, the embryo density, and so many things. Get that right first. And once you are convinced about the incubator, then try changing the media. Do not change two things simultaneously.
Wonderful.
This is what I would like to
Dr.
say.
Sudesh, any inputs out there?
No, same, nothing more to add. But see, I have not noticed any difference whether it's a benchtop or a box incubator. Both work equally good for us. I recommend, always you need to have a box type, because media and all you can't keep in a benchtop. And benchtop is more, for space saving and all that. And of course, you're getting better results, blastocyst conversion, but even equally good we are seeing in box type. And like I will also, why do you need to change? Use whatever is giving you good results. Never change your media. That's the most important.
So I think we really need to plan the number of times we are opening and how we are placing our this. That is what probably would also help them have better outcomes, whether it's a benchtop or a box incubator. But I think Dr. Sarabjit wonderfully showed those little slides where he said hypoxic oxygen culture conditions probably would give us better blastulation and better implantations and live birth, as shown by the Cochrane database. Quick points from my seniors out here. Dish preparation, such a basic fundamental skill. And we so many times see things just going haywire with these little things. So some tips and tricks, I've just put in some thoughts there. But for all the people who are out there, this fundamental dish preparation step, out of your experience, what are those important things which would really help us get the best outcome?
Yeah, okay, please.
No, see, you should understand that your dish preparation skills are much more important than your ICSI skills. Okay, everybody should understand, because see, you can have Sudesh Kamath in your lab, but if there is someone who's not preparing your dish well, and if the osmolality is changed very badly, if the pH of the media droplet is changed very badly, then you are going to have very poor outcome. So dish preparation is a very, very, very important thing, and it should not be taken lightly. Now, if you are handling very small media volume, say for example 20 microliters of droplets, then definitely it would help to have two people to do the dishes simultaneously. So one makes the droplets and the other one just lays oil over it. Instead of trying to do droplets first and then you put oil over it, you have to have at least two people to do this simultaneously. Then There is a very nice paper by Jason Swain. I do not know if you can get the reference now, but the thing is, everybody should read it, where he has said it would help if you can turn the laminar airflow off if you are dealing with very small volume, and you also turn the laminar warm stage off when you're preparing your dishes. I think these are the very basic things. And then, of course, you have to handle it in a very sterile way and without contaminating the media. I think these are the major points.
Sudesh sir, if you would just want to throw some light, any additional point?
Yeah, that's what we also do. There are two persons who help in preparing a dish. But what if you're all alone? Then I'll advise just do one dish at a time.
Exactly.
Prepare one dish. Once that's over, everybody wants to do shortcut, make 4 or 5 dishes at one time, but that is not advisable, especially if you're doing droplet culture. Any rapid changes and other things, like preferably if you can even make dishes a day before with cold media, so there will be less changes.
Wonderful.
Then keep it.
Wonderful. Gaurav, if there was any additional point that you wanted to share with us, Gaurav?
When you are making the dishes, don't take out all media together. So if you are making a fertilization plate, take out only fertilization media and the oil at that point. Don't take out the HFS and the blastose media and the cleavage media together. So whatever you're making, just take out those media. And so, if I talk about preparation, you just have no airflow, no temperature, and minimum number of dishes at one time.
Media volume, if we could quickly touch on that. Where, what is the minimal, we could make a 0.5 ml in a dish, but 10 microliters, 20 microliters, 5 microliters. If I had to pick in 3 volumes, what would be your recommendation?
But I think it would depend on the number of embryos you're going to place in that. Okay. There is a paper which says that for every embryo, you need to have a minimum of 15 microliters of media. So what we generally do is, like, we make around 45 to 50 microliters droplets where we place in 3 embryos. But I think it again depends on your culture conditions. But this is a recommendation.
Wonderful, wonderful. So, if there are no more additions, we'll just go to the next slide. The last scenario. I think we've just hit 7 o'clock. 5 more minutes, we should be done. I think this is a general thing for all my seniors out there, even for Charujat Joshi sir and Sanjay sir and Vedji. KPIs. I think this is a constant thing that all of us are picked on. So if at all we are in a situation where FERTs was 72%, but the blastulation was only 27%. And they were doing a freeze-all policy. Their beta HCGs were wonderful, but there was a lot of pregnancy loss in terms of biochemical loss and miscarriage. And I know they started off with a 70% beta HCG, but they ended up with a 23% live birth. How would you actually recommend we go in a situation like this?
See, if you just look at it in a very broad way, okay, any embryo arrest before 8 cell stage, to a great extent, it depends on the quality of the oocytes. And if it happens beyond 8 cell stage, then, like, it means there's some issue with the embryonic gene. And sometimes it could be because of the paternal contribution also. So having this in mind, but this doesn't answer all this question. So we can, take you from this particular point, but you have to look at every small thing in your laboratory, which could have, made an impact on your blastocyst formulation. Yeah.
So the media, all that thing what we just discussed. So the incubator media quality, because your blastulation as per the Vienna consensus should at least be 40%. And since this lab is only getting 27% on an average, I think they need to look into the microculture conditions. But now, as an embryologist, I would be very happy. 72% people got positive results. And then, I don't really think I would really get the first-hand information of biochemicals and miscarriages. Now, do we really blame the lab here?
One thing which probably we are missing, like just the extension of what Sujata answered, fertilization rate 72% is okay, perfect. But we haven't mentioned anything about what was the quality on day 3. So again, the paternal factor comes in the picture.
Mm-hmm.
So are we doing something wrong with the sperm preparation? Because it does have a epigenetic as well as the sperm DNA fragmentation problems with the sperm preparation.
Okay.
So sometimes, even if it's an old lab, if a person working for several years, there may be complacency that creeps in sometimes, and you are neglecting the most, probably considering that this is not as important as other factors in embryology. So your sperm preparation techniques must be reevaluated. This
Wonderful.
could also cause the miscarriage.
All right. So it's going to be multifactorial. So it's a good thing to have a checklist where, you know, every time you have a failure thing, you kind of go fill in as to know what are the things in that batch or that month, and that the root cause analysis or a YY analysis probably gets you to the bottom of it. But yeah, so I think it's not a one word answer. You will have to be looking at a bigger picture out there, and there can be a component of lab for your biochemicals and miscarriages to go up. It's not completely clinical, and we probably are a part of that blame game. Everybody agrees with me on that?
Yes.
Definitely.
All right, wonderful. So last few quick one-word answers, if we could get your expert advice. Cleaning detergents, you know, do we pick whatever is there, or is there a science that we should be looking at?
We have to look at the science, definitely. Something which is non-toxic.
Okay. So there's absolutely no for alcohol, or is there a slight relaxation for 70% ethanol to get into the lab?
No, we don't
No
use
alcohol.
alcohol. Yeah,
No alcohol in the lab.
Okay. Now in COVID times, there are recommendations which said, you know, at the end of the day, for 30 minutes, run your UV light and then shut the lab and go. Do you recommend yes or no?
Yes.
So
it's a must.
the embryos are in the incubator, and I could still switch on the Laminar Airflow
Yes.
UV, and that would not affect my culture conditions,
It wouldn't
embryo
affect.
development at all.
But only thing is you have to take care of your perspex and plastics, because UV can actually cause cracks in them. And then, you know, like you don't want that to happen. So you have to put your plastic pipette handles and any other plastic things somewhere away from the UV.
So many labs nowadays, we see a lot of, you know, fancy cabinets coming, sometimes made of stainless steel. But, you know, the entire stock is inside the laboratory. So it's easy for the embryologist to pick what they want. I would love to have something like that, but do you recommend doing this?
No.
Even if I'm outgassing it, you wouldn't recommend me to do that?
No clutter, no storage in the lab.
Okay. All right. Dr. Sarpreet, I think you had something and we did not listen to you.
Regarding UV light, I would like to say that the AHUs need to function properly. You know, you should have minimum 15 air changes, you know, in order to switch on the UVs. Otherwise, I won't advocate the use of UVs in a poorly ventilated lab.
Not only that, Sarpreet, UV light is a broad thing. UV spectrum is very broad. So specifically UVC light that can be used in the laboratory, and that too in the range of 253 nanometer probably. So that is safest spectrum to use in the lab.
So I know, I think there's minimal furniture in the lab, but, you know, is there any science there that, you know, it has to be a particular thing, or would you recommend anything is okay when it comes to the stools or the chairs that we are sitting in the laboratory?
No wooden chairs.
No wood, wonderful. But is Rexine or leather allowed?
We have small stools, you know, steel stools. No Rexine, no wood. It can release aldehydes and all, you know, VOCs.
But, you know, on the day I'm doing a TISA XC, ask me, my back hurts sitting on
all of us, we have back problems, all of us.
Wonderful. But ergonomics, I think our posture and how you sit, how you do really matters a lot. So I think a due thought with how you're sitting should be addressed to your team.
So keep yourself fit.
Yes, absolutely. You know, I was told by my teacher, you know, I used to be lost doing ICSIs for 2 hours, and then he used to say, there is jang nahi lad rahe ho. Utho, 10 minute bahar jaake hawa kha ke aao. You're not going to get extra perks for doing ICSI back to back and finishing. You know, he says 10 minutes, nothing is going to go wrong.
Yes,
liquid nitrogen. And I think this is one thing that, you know, we freeze in the same laboratory where everything is there, and it is a closed space. Are there any health hazards, concerns, or effects to the embryo culture system?
More than the
a liquid
embryo culture
nitrogen box.
system, so that's okay. Like you can bring in the liquid nitrogen box and you can take it. But then I have seen people storing liquid nitrogen tanks in the laboratory, which is a strict no-no because, you know, it's a closed place and you need to have oxygen monitors in the lab if you are going to do that. Otherwise, the embryologist can get asphyxiated. Definitely, that's a no-no.
But a little box of liquid nitrogen for me to vitrify is
No,
not a
that
matter
should
of
be okay.
concern.
No, that should be okay because
Wow.
anyway, you have your air handling system running and then it can take care of the
How will
nitrogen.
you
Yeah.
vitrify if you don't bring it in?
So the
Yeah,
main
yeah.
thing is that when the liquid nitrogen part is outside, don't bring the embryos and check the embryos. Do vitrification, that's it, and take the pod outside.
Exactly.
That's the main thing. Don't do other things at that point.
All right. So we've always known that, you know, we want minimal people movement, but, you know, egg collections, transfer times, still there's a lot of movement. One quick last point from you all, is there some recommendation? Or it's okay because I've got a AHU which is working very well. I'm not really should be bothered about this movement of people or number of people in the lab.
We used to have earlier only 2 people in the lab at any given time. Now we have brought it down to 1. Only when we are doing witnessing, then the second person just walks in. Otherwise, presently only 1 person in the lab at any one given time. In COVID scenario.
I have a sticker outside my lab written only 3 brains are allowed inside.
Okay.
Not more. Yeah. So one is the shadow is always
What OT?
Yeah.
What about OT? What about the theater? How many are allowed?
No, theater, so you can't help it. You need a lot of people when you're doing the procedure. And we are talking about the lab.
No, you need just 3 people in theater also, a technician, an anesthetist, and a gynecologist.
And again,
Minimum
it depends
3.
on the size of the lab, Krishna. Like if you have a very small, you know, less than 100 square feet lab, then even 3 is a bit too much. You know, like I think you have to have just 2 people at a time. One for doing the procedure and one for witnessing.
Charu sir.
Yeah, I would like to add one more thing. As Dr. Sarapit said very correctly, see, we have to see not only in the lab. In lab, you can always control. You can always say 1% or 2%, that will be fine. But outside in OT, the control is not in our hand. And many times in my experience, I have seen more than 5 people, 6 people, just few people are visitors over there. They are just there for watching how to do the embryo transfer and all. So this all is going to affect not in the lab, but when you bring that embryo loaded outside for transfer, it is having some effect. So either we should have a consent with the doctor that if there is more people, we are not responsible for the compromise in
Wonderful. Wonderfully put across
otherwise
there.
there should be restriction for people.
I'm sure. I agree.
I had a chance to visit few places where they are more in training program also. And at same time, at the time of pickup, there are more than 10 people are standing there just to observe how to do the pickup.
Training should be kept.
Particularly the units which are there in the institutes, like some medical college. So they said, sir, what we can do, it's a institute, so we have to ask other doctors and other consultants of the hospital to come and see.
Yeah.
But then if you are doing a practical case on a patient, then it should not be done.
So that was a wonderful panel from all our seniors out there. I think the idea was to bring across the message loud across. I think your SOPs are important. They need to be updated. They have to have protocols, policies in place. There isn't a one-word answers for your problems. Problem is the norm of the day. And that is what is making you an experienced embryologist. So your documentation, timely audits, and troubleshooting it is what is going to help us really do it. And this is never a one-time thing. This is going to be a frequent affair. Even the best lab with the best embryologist can come across issues. So embryo culture system is the essential fundamental thing. And it is quite a multifactorial thing. You've got to be having a broader perspective. So that is what all our seniors and expert panelists today have put across. I'm hoping each one of you have enjoyed interacting with our panel out here today. Thank you so much, each one. Thank you for Dr. Ved and Dr. Charu for this initiative. It was wonderful discussing. Thank you, everybody. Dr. Sanjay, I think if there's anything more that you want to add.
Wonderful. I mean, there is just one word for this. The only thing is that we have too many questions lying before us, but probably we are running short of time.
Dr. Ved and Dr. Sanjay, we could probably personally answer them.
Yes. So what we can do is probably we can answer them personally. And I would also like to thank you, Krishna, because not everyone knows that you are also going through some tough time. It is wonderful to know that you have spare your time. You have also dedicated to your parents who are suffering from the COVID, but
with all your good wishes, they've recovered very well, and in fact, I'm taking them for chest physio, which is good. But anything for you all.
So thank you very much for coming down and accepting my request to take over my burden and taken it so wonderfully. Thank you one and all for this wonderful webinar, and we would continue with this series in the upcoming time. Next webinar is our international faculty, Professor Gabor Vata, who is also an attendee today. So it's a great honor to have him in the participants. And another renowned personnel, Ms. Asthavaya. So we would be continuing our efforts to bring down some of the world's renowned personality to you and answer your questions and satisfy your knowledge hunger. Thank you very much. Thank you, Sahana, and it's over to you, Dr. Ved.
Thank you, sir. I personally want to thank everybody, my speakers and panelists, who done very good job. And this is wonderful to know that this time we had so many questions, but sorry to say that we have no time left. So we will answer them personally. And one more thing I want to tell that there are so many participants this time who attended since starting to end. They are still with us. So it is very good. And I want to thank Zydus Cadila for supporting this event. And many thanks to Mr. Sudeep Mukherjee and his team who has helped us to doing this wonderful webinar. So over to Sudeep for closing remarks.
Sir, my apologies because I was supposed to join in the beginning to greet and thank you all, but I was having some internet issues. I joined, then I logged out. But then I was, this entire panel discussion, I was there. And I always tell my team that the amount of insights and knowledge that as an external person I get when I attend these panel discussion, especially these webinar series, really gives me a lot of insights, sir. And thank you very much. Thank you all for sparing time and giving this opportunity to Zydus Gynova division to collaborate and host this wonderful academic meet. As sir, you have already announced the next program, which is 14th. We look forward eagerly for again a great academic meeting. And thank you all for collaborating with us. Thank you, sir.
So thanks everyone. It was wonderful to be part of the panel, especially Dr. Krishna, Dr. Shukla, Ved, Dr. Sujata, Sarabpreet, each of Gaurav. It was wonderful learning experience for me. Just one thing, all of you, please, everyone, take care. COVID,
sure.
Yes, please take whatever precautions, protection you can. Take care, stay safe. That's all I would like to say. Thank you.
Thank you. Good night. Happy weekend to everybody.
Thank you. Thank you, sir. Happy weekend all. Thank you very much.
Thank you, sir. Thank you. Please take care.